Hi everyone! Today we are going to talk about something that seems impossible. The lightest reservoir monitoring system you could think of. One seismic source and one receiver location to detect a 4D effect in the subsurface. My name is Elodie Morgan and I'm the co-founder and CTO of Spotlight. Now here is the field case. We were for 7 months on a gas storage field and we had to monitor the pressure variation on 4 spot locations. Now, let's be honest. Thanks to one source and one receiver location, we will not be sensitive to a seismic bin, but we will be sensitive to the Fresnel zone. So in that case, the Fresnel zone is a 300-meter diameter, and you can see the true scale on the image on this slide. Now, how can we know where to locate the source and the receiver to monitor a 4D effect on that spot? Well, on the field, we are not completely blind. We have the 3D seismic data. So we can perform the ray tracing algorithm on the migrated data to retrieve all the source and receiver locations that have contributed to the final image of the spot. Now that we have this source and receiver location, we can build the common spot gather from the raw seismic traces and perform the optimum selection based on signal-to-noise ratio and surface constraint so that it would be practical from the truck to go from one source position to the other. Here you can see we have 3 source locations and 6 hydrophone antennas to monitor for the effect on these 4 spots. Now we had to build a specific processing sequence which relies mostly on temporal stack. And you can see that on the left side of this slide, we have the raw seismic data and we have a bad repeatability with 60% normalized root mean square. And on the right side, you can see that we reach 12% in RMS, which is a very good repeatability for an onshore reservoir monitoring system. Thanks to this processing sequence, we can now detect the 4D effect in time shifts at the gas storage level. Now let's see the correlation between the detection and the pore pressure variation, which is the black dotted line in this graph. You can see that when the pore pressure increases, we have a decrease of P velocities, and so we have a positive time shift detection. This is coherent with this injection phase. And then we have the opposite effect during the depletion. The second thing that we can notice here is that the curve belonging to the spot number 3 is reacting before spot number 1 during the depletion. This is due to the fact that spot number 3 is more on the edge of the gas storage compared to spot number 1. So we were successfully able to detect 4D effects due to the gas storage activity on this field. What can we do next with such a light and cost-effective reservoir monitoring system? We can trigger the on-demand monitoring, where you could place a light reservoir monitoring system anytime you need it and where you need it to answer your production scenario uncertainties. And then you can also think about the offshore application for such a novel operational model. Now, so I would like to thank OMV for their support and for allowing me to publish this work. And of course, I would like to thank Rosing for the field acquisition, the expert committee from Spotlight, and Michael, Alexandre, Yessine, Kevin, and Jean-Luc for their contribution to this paper. Thank you.